everyone, good day. This is Group 5, the activity number 5. So we have the title of the importance of data management, and also we have the theme understanding the importance of data management in all aspects of mathematics. So today we are going to tackle 3 topics, which is gathering and organizing data, second, measurement of central tendency, third is measurement of relative position, and also we provide each topic an example. So let's proceed to the discussions.
Gathering and organizing data. Collecting data is when you gather information in mathematics, which you can then organize and analyze to answer questions. To do this effectively, you need to know about different data collections method. First, let us consider the different types of data you can collect. Categorical data is the statistical data comprising categorical variables of data that are converted into categories. One of the examples is a group data. More precisely, categorical data could be derived from qualitative data analysis that are countable, or from quantitative data analysis grouped within given intervals. These data are summarized in the form of a probability table. Ordinal data is a kind of categorical data with a set order or scale. For example, ordinal data is said to have been collected in your standard inputs, his or her financial happiness level on a scale of 1 to 10. In ordinal data, there is no standard scale on which the difference in each score is measured. On a continuous scale, respondents rate the objects by placing a mark at the appropriate position on a line that runs from one extreme of the variables to the other. The form of the continuous scale may vary considerably. Independent variable is a variable that stands alone and isn't changed by the other variables you are trying to measure. For example, someone's age might be an independent variable. Other factors such as what they eat, how much they go to school, how much television they watch aren't going to change a person's age. A dependent variable is exactly what it sounds like. It is something that depends on other factors. For example, a test score could be a dependent variable because it could change depending on several factors, such as how much you studied, how much sleep you got the night before you took a test, or even how hungry you are when you took it. Controlled variables are properties that researchers hold constant for all observations in an experiment. While these variables are not the primary focus of the research, keeping their values consistent helps the study establish the true relationship between the independent and dependent variables.
The data gathered shall be presented, analyzed, and interpreted that can be easily understood by the reader. Data may be presented, and these are textual, tabular, and graphical presentation. Textual presentation, the data gathered are usually in paragraph form, and it's usually used when there are only few data to be presented. For example, there were 68 females and 32 male in study conducted on the sports they played. As you can see, the sample presented are the data are made up of text and numbers. Next presentation of data is the tabular presentation. It is the systematic and logical arrangement of data in form of rows and columns with respect to the characteristics of data. It is make use of tables. Say for example, it is composed of 6 of statistical table. These are table heading, stubs, box, head, body, source note, and footnote. And lastly, the graphical presentation. Data can be presented visually using graphs, chart, or diagrams, and using this strategy. We may examine the causal connection between two variables, and here are the examples: bar graph, circle graph, line graph, and pictograph.
Measurement of central tendency. Central tendency determines a numerical value in the central region of a distribution. Of course, there are 3 measures of central tendency: the mean, the median, and the mode. So what is mean? It is also called the arithmetic of mean or average. It can be affected by extreme cores. It is stable and varies from sample to sample. It is used if the most reliable measures is desired, and when there are few with very high values and a few with very low values. The mean is the balance point of a coarse distribution. To compute the mean, AR ungroup data. Formula: mean is equal to sum of values divided by the number of values. Examples: find the mean of 5, 7, 11, 20, and 18. Another example: find the weight arithmetic of mean of the numbers 12, 15, 16, 12, 15, 18, 18, 20, 12, and 18. Solution: mean is equal to 12, we have 3, 12, and we have 15, 2, and we have 18, 3, and we have 16 and 20. Divided by 3 plus 2 plus 3 plus 1 plus 1. So, 12 times 3 is equal to 36, then 15 times 2 is equal to 30, then 18 times 3 is equal to 54, plus 16 16 plus 20 is equal to 36 over 10. So 36 plus 30 plus 54 plus 36 is equal to 156. Divide by 10. So 156 divided by 10 is equal to 15.6. That's the final answer. So our total frequency here is 33. And the sum of products of mean interval values in their corresponding frequency is 186. Solution. Mean is equal to the sum of products of mean interval values in their corresponding frequency divided by total frequency. 186 divided by 33 is equal to 5.636 or 5.65. What is median? Median is obtained by inspecting the middlemost value of the arranged distribution either in ascending or descending order. It can also be solved using the formula number of sample plus 1 second position after being. Examples 1, 2, 4, 5, 5, 6, 8. Here the middle observation is 5, so the median is 5. Another example 1, 3, 4, 4, 5, 7, 8, 8. Here there is no middle observation, so we take the average of the two observations at the center, which is the 4 and 5. So median is equal to the number of sample plus 1 divided by 2. 4 plus 5 over 2. 4 plus 5 is equal to 9 divided by 2. So 9 divided by 2 is equal to 4.9. Examples, the following distribution of mathematics scores of 20 students. So our less than cumulative frequency is 4, so our lower class containing median is 4.5. Median formula. Low median is equal to the low class containing the median plus, open parenthesis, the number of sample divided by 2 minus less than communicative frequency, close parenthesis, times weight of the class divided by frequency of the class containing median. So 4.5 plus 20 divided by 2 minus 4 times 2 divided by 8. So we need to solve first the open parenthesis. 20 divided by 2 is equal to 10 minus 4. So 4.5 open parenthesis 10 minus 4 times 2 divided by 8. So the answer is 6.
Mode. Mode is the value that occurs most frequently in the distribution. A distribution can be unimodal with one mode value, bimodal with two mode values, and lastly, it can be trimodal with three mode values. In other words, it can have more than one mode. So how to find mode? There are two ways to find mode. First is ungrouped data. Second is grouped data. So what is ungrouped data? You can find ungrouped data by merely inspection. For example, find the mode of the following. Now, as you can see, 7% has the largest frequency. So in other words, mode is number 7. So let's move on to group data. You can determine group data by finding the highest frequency in the model class. For example, in finding the mode of group data, we have this formula. First, we need to find the lower boundary, which is number 10. Just subtract it to 0.5, we can get 9.5. After that, just find the difference 1. Just check the below of the highest frequency. Since there is no frequency below number 14, just subtract it to 0 and we still get number 14. And the difference 2, just check the above the highest frequency, just 10. Subtract each other, then get number 4. Then the class interval is number 2. So first, add number 14 to 4, get 18, and divide 14 to 18, and times 2, we can get 1.56. Just add these 2 and we can get 11.06.
Percentile is defined as the value below which a given percentage falls under. The formula for percentile. Percentile is equal to n over n times 100. Or the percentile of x is the ratio of the number of values below x to the total number of values multiplied by 100, where n is equal to ordinal rank of the given value or one value below the number. N is equal to number of values in the data sets. P is percentile. Example, the score obtained by 10 students are 38, 47, 49, 58, 60, 65, 70, 79, 80, 92. Using the percentile formula, calculate the percentile for score 70. Score obtained by students are 38, 47, 49, 68, 60, 65, 70, 79, 80, 92. Number of score below 70 is equal to 6. Using the percentile formula, which is percentile is equal to number of values below x over total number of values multiplied by 10. Percentile is equal to 6 over 10 times 100. So percentile is equal to 0.6 times 100 is equal to 60. Therefore, the percentile for score 70 is equal to 60. Percentile for ungrouped data. Example, find the percentile 50 of the following set of data. 19, 12, 16, 0, 14, 9, 6, 1, 12, 13, 10, 19, 7, 5, 6, 8. Now, let's arrange the data set to ascending order. 0, 1, 5, 6, 7, 8, 9, 10, 12, 12, 13, 14, 16, 19, 19. So this is the formula to find the percentile 50. Percentile 50 is equal to I times n plus 1. N is the number of data sets over 100. So percentile 50 is equal to 50 times 15 plus 1. 15 plus 1 times 50, that is 800 over 100. So percent of 50 is equal to 800 over 100. We divide the 800 to 100. So the answer is 8. The percent of 50 is the 8 data. And the data set, the 8 is the 10. So therefore, the percent of 50 is the 10. Percentile for group data. Example, we will calculate the 37th, 45th, and 19th percentile from the frequency distribution of weights of 120 students by using this table. From P sub 37, P sub 45, and P sub 90, we have concluded or interpreted that 37% students weigh 147 pounds or less. Similarly, 45% students weigh 151.1 pounds or less, and 90 students weigh 182.83 pounds or less.
What is quartile? Quartile divide the rank ordered data set into 4 equal parts. Statistical term that describes the division of observations into 4 defined intervals based on the values of the data. So this is the formula where I is equal to 1, 2, 3. So this is stand for quartile 1, quartile 2, and quartile 3, where n is the number of samples. So let's have these examples. Number 1, let us find the quartile 1, quartile 2, and quartile 3 of the following set of data. So let's start with the quartile 1 first. So what we need to do is to arrange the data in ascending order. Now again, this is the formula of the finding the quartile now. Since we're finding the quartile 1, our I is 1. So this is now a sub 1 is equal to 1 times R. Our N is 15, so we have 15 number of samples here. Plus 1 over 4 now. 15 plus 1 is 16 times 1. That is now 16 over 4. So 16 divided by 4 is 4. So meaning the quartile 1 is the fourth data. So we're going to count. So the fourth data from the smallest value is 1, 2, 3, 4 is 6. So therefore, the quartile 1 is 6. Let us find the quartile 2. Again, arrange the data in ascending order. So now, since we are finding the quartile 2, our I now is 2. So let us now, A sub 2 is equal to 2 times, again, we have 15 number of samples. Plus 1 over 4. 15 plus 1 is 16 times 2. That is 32 over 4. 32 over 4 is 8. So meaning quartile 2 is that 8 data. So 8 data is 1, 2, 3, 4, 5, 6, 7, 8. So the 8 data is 10. So let us find quartile 3. Again, arrange the data in ascending order. So by this time, our I is 3. So we have A sub 3 is equal to 3 times. We have 15 number of samples. Plus 1. So 15 plus 1 is 16 times 3. That is 48. So over 4. So 48 over 4 is 12. So quartile 3 is 12 data. So the 12 data is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12 data is 14. So therefore, quartile 3 is equal to 14. So when quartile 1 and quartile 2 are not integers, the quartile 3 are found by interpolation. Another one gives us mean 65 data into 10 equal parts into which population can be divided according to the distribution of values of a particular variables. So this is the formula for finding the daysels, where I is equal to 1, 2, 3 up to 9. This stands for daysel 1, daysel 2, daysel 3 up to daysel 9. N is the number of samples. Let's solve the sample number 1.